Okay. Am I audible to all of you?
Yes, sir.
Okay. So we are going to start the new topic that is the part of electrochemistry, and it is a redox reaction. To do the electrochemistry, it is prerequisite to understand the redox reactions. So in AS level, we have redox reactions, and in A2, we have electrochemistry. So we are going to start with redox reactions today. Okay, another thing. Okay, I will discuss. Do remind me at the end of the class, I have to discuss something, okay? Okay, so the first thing in redox we are going to discuss is oxidation number, or we also call it oxidation state. So when we talk about oxidation number or oxidation state, so we can say it is the charge, or you can say value of the charge given to an atom or ion. From oxidation number, we can identify the number of electrons it has the and second, the number of electrons gained or lost. Is this understandable to all of you?
Yes.
Yes, sir.
Okay. Positive oxidation number indicates that electrons are lost and negative oxidation number indicates that electrons are gained. Are these two statements are clear to all of you?
Yes, sir.
Okay. So let's have a look at few examples. For example, there is P4. Then there is Zn2 positive, Ag plus 1, nitrogen 3 minus, which is called nitrite, and sulfur 2 minus. So if I assign the oxidation number to these atoms or ions, so the first one is an element, so its oxidation number is 0. Its oxidation number is 2 plus, its oxidation number is 1 plus, its oxidation number is -3, its oxidation number is -2. Further, we can say no electron gained or lost over here. Just give me a minute, please. Okay, now as the oxidation number is 0, it's an element and there are atoms in the molecule, so we say that there is no electron lost or gained because the oxidation number is 0. Here its oxidation number is 2 positive. It indicates 2 electrons are lost. It indicates 1 electron lost. It indicates 3 electrons are gained as the oxidation number is 3 minus. And it indicates 2 electrons are gained. Is this clear to all of you? Yes, Ashal, Hamza,
Yes.
and Kubra?
Yes, sir.
Yes, sir.
Okay. Now, we are going to discuss the rules for determining oxidation number. So, the first rule states that the oxidation number of an uncombined element, and when we use the term uncombined element, it means that it must not be bonded to any other element. So the oxidation number of an uncombined element is always 0. Is this point is clear to all of you?
Yes, sir.
Ji, sir.
Okay. Here we have an example. And then the oxidation number. So, for example, we have zinc, chlorine, phosphorus, sulfur, aluminum, hydrogen, etc. So the oxidation number of all these, as they are not bonded to any other element, so their oxidation number is always considered as 0. And it also means that no electron is gained or lost. Yes, is this clear to all of you?
Yes, sir.
If any one of you have any confusion, please ask. Okay, now second point. Or second rule. In compounds, the oxidation number of metals is always positive. Now, if the metal, it depends on the group. So, the metal can be in group 1 or group 2 or group 3 or from group 4 or transition metal. So these are the groups which usually contains metals in the periodic table. So the oxidation number of group 1 metals in compound is +1. Group 2 metals in compound is +2. Group 3 metals in compound is +3. For group 4 metals, they are either +2 or +4. They have oxidation number. And transition metals have a positive oxidation number, but it varies from +1 to +7. Is this clear?
Yes, sir.
Yes, sir.
Okay. Now, zinc always form zinc 2 positive ion. It doesn't have a variable oxidation state. In the same way, scandium always form scandium 3 positive ion and mostly silver forms silver plus 1 ion. So these three you have to remember. Beside these three, you can always figure out from the periodic table or the rules that we are discussing. Okay. Till here, if any one of you have any confusion, please ask. Yes, is this clear?
Yes, sir.
जी
Okay.
sir.
Now, third rule. In compounds, the oxidation number of non-metal elements is always negative if bonded with metal. So if a non-metal is bonded with a metal in a compound, then the oxidation number of that non-metal is always going to be negative. So here we will see the group number and the oxidation number, that how we will figure out the oxidation number of non-metals by the help of group. So non-metals usually present in group 4, group 5, group 6, and group 7. So group 4 have usually -2 oxidation number. Group 5 have -3 oxidation number. Okay, it is usually from -2. Okay, group 6 have -2 and group 7 have -1 in most of the cases. Is this clear?
Sir, why won't it be -4, -5, -6, -7?
No, it could not be, because group 4 have a 4 electrons in its valence shell, so maximum it can gain 4 electrons. So in some cases it can be -4, but I am giving you the oxidation number which is present, which are actually on these atoms in the compounds in most of the cases.
Okay. And sir, what if they would be bonded with non-metals? So it would be positive or negative?
What?
If non-metals are bonded with non-metals.
That's what I'm going to discuss. I didn't discuss it yet.
Okay.
That is our
Okay.
fourth point. if two non-metals are bonded to each other in a compound, then more electronegative has negative oxidation number and less electronegative has positive oxidation number. So in bonding, we have discussed the electronegativity and we discussed the electronegativity order and first the most four electronegative elements. Can anyone recall?
The fluorine, oxygen,
Good. That is formed.
nitrogen.
The most electronegative one is fluorine, then oxygen, then nitrogen, and then chlorine. So in the presence of fluorine, if fluorine and oxygen are bonded, then oxygen is going to be positive, has positive oxidation number. In the same way, when oxygen and nitrogen are bonded, then nitrogen is going to has a positive oxidation number and oxygen have a negative oxidation number. Is this point is understandable? Yes, is this point is clear to all of you?
Yes, sir.
Now, fifth point. The sum of oxidation numbers of elements present in a compound is always equals to 0. And that's why we always see there is no charge on a compound, like carbon dioxide is CO2, no charge, sodium hydroxide is NaOH, no charge. So it indicates that whatever the elements which are present in the compound, their atoms or ions have oxidation number. When we add those oxidation numbers, it always gives us the 0. That's why those compounds have, that's why all the compounds have no charge. Is this point is clear?
Yes, sir.
Okay. Yes, Ashil, I hope all of these clear to you as well. Okay, now point number 6. The sum of oxidation numbers of elements present in polyatomic ions is equal to the net charge.
Sir, can you remind polyatomic ions?
Yeah, like hydroxide, OH negative, sulfate ion, SO4 2 negative, the ones which have more than one element in them and they possess some charge. So that charge is basically the sum is equals to the sum of the oxidation numbers of the elements present in that ion.
Okay, sir. Thank you.
Here example is hydroxide, sulfate, it's SO4. And let's say ammonium, etc. Yes, is this clear to all of you?
Yes, sir.
Yes, Kubra,
Yes.
yes, Ashal. Now, after this, you have to know and keep this placing order in mind, that when you are going to place the oxidation numbers of the elements in the compound or an poly or in a polyatomic ion, so you always follow this order, that which element you will put its oxidation number first and for which one you will put its oxidation number later. So that is the order. So first and foremost, identify the net charge. So that net charge can be 0 or it can be a positive or it can be a negative depending on it's a compound or a polyatomic ion. First place that net charge, then if there is any metal from group 1, 2, and 3, then put its oxidation number. Any metal from group 1, 2, or 3. If the metal from these 3 groups are present, then put its oxidation number, which is either +1 for group 1, +2 for group 2, and +3 for group 3 metals. Is this clear to all of you?
Yes, sir.
Then at third place, put the oxidation number of hydrogen if there is a hydrogen in that compound or polyatomic ion, and the charge for hydrogen is either +1 or -1. Then at fourth, put the oxidation number of most electronegative element, which is always obviously negative. After this, if there is any other element left, put its oxidation number. Any other element left, if there is any other element, put its oxidation number. And then keep in mind that when you are putting the oxidation number for the last one, put it in such a way that the sum of oxidation numbers equal to net charge. Yes, are these points are clear to all of you?
Yes, sir.
Yes, if any one of you have any query, please ask. Okay, now I have a few examples that I will do over here, and you will practice along with me so you can understand. Then there is a task that you will do and send me in the next class. Okay, what I want to discuss is, I was thinking that might Ahmad and Amna may join. Actually, on Friday, we will not have any class due to my exam. So, and in the coming week, I will discuss with all of you guys and then schedule all the missed classes, okay?
Okay, sir.
Okay. Now, let's do it. For example, if I have to find the oxidation numbers of the elements present in this compound. So, look over here. What is the net charge on this compound? Yes,
0.
0. So I will put a 0 over here. Now tell me if there is any element from group 1, 2, or 3. Yes, tell me any element from group 1, 2, or 3.
Yes, sir. Na.
Na. So the charge of Na is going to be +1, and there are two Na, right?
Hmm.
After this, Na is in group 1. Is there any hydrogen?
No, sir.
Okay, so the net charge becomes +2. If you look over here, there is no hydrogen, then the most electronegative one. Oxygen is here, the most electronegative one, and it's in group 6, so its oxidation number is going to be -2. So -2 times 7 makes it -14, isn't it? So now think, sorry,
Sorry about the 14.
it's -14. So what number with a charge we can put in the middle to get the net charge 0? Yes, Kubra?
Sir, +12.
+12. And how many atoms of chromium are over here?
2.
2. So if there are 2 atoms, then what will be the oxidation number of each chromium?
6.
+6, not 6. Is this understandable?
Yes, sir.
Yes, Ashal. Yes, Kubra.
जी sir.
Okay. That's how we always find the oxidation number of the elements present in the compound or the polyatomic ion. Let's have a look at another example. It's F2O. So what is the net charge over here?
0.
0. There is no element from group 1, 2, and 3. There is no hydrogen. Which one is the most electronegative?
F.
F. Fluorine belongs to group 1, group 7, so it have a -1 oxidation number, and there are 2 fluorine, which makes it -2. Net charge is 0. So what will be the charge or oxidation number of oxygen over here?
+2.
+2. So +2 will be the oxidation number of fluorine of oxygen in this compound. Yes, is this clear?
Yes, sir.
Yes, Ashal and Kubra.
जी sir.
Now, third case, H2O2. Let's do this. What is the net charge?
0.
0. No element from group 1, 2, and 3, right? But there is a hydrogen which is bonded to oxygen. So now the hydrogen's oxidation number is going to be +1. And there are 2 hydrogens. So the net charge of the 2 hydrogen is +2. And the net charge of the whole compound is 0. So what will be the charge on oxygen?
-2.
Sorry,
-2.
-2. And how many oxygen atoms are here?
2.
2. So what will be the charge on each oxygen atom?
-1.
-1. So that's how we identified the oxidation number of oxygen and hydrogen in this compound. Is this understandable?
Yes, sir.
Yes, Ashal and Kubra.
जी
Okay. Now have a look at another example. NaO2. What is the net charge?
0, sir.
0. Is there any element from group 1, 2, and 3?
Any.
Yes.
No,
Yes.
sir.
Which one? Yes, which one? Yes, is there any element from group 1, 2, or 3?
Sir, any from group 1.
Group 1. So its oxidation number is +1, right?
Yes,
So
sir.
if the oxidation number of oxygen is +1 and the net charge is 0, then what will be the oxidation number on oxygen?
-1.
-1. But if you see how many oxygen atoms are here?
2.
2. So if there are 2 oxygen atoms, then what will be the oxidation number on each oxygen atom?
-0.5.
-0.5 or -0.5. So that's how, see, we are able to identify the oxidation numbers of the elements in this compound correctly. Is this clear to all of you?
Yes, sir.
Yes, Kubra and Ashal?
सर मुझे हाइड्रोजन का समझ में नहीं आया वो +1 और -1 कब होगा
Well, that's what I'm going to tell you in the upcoming examples. Just wait. See over here, it's H2O. So, what is the net charge? Yes,
0, sir.
0. Any element from group 1, 2, and 3?
No.
So then hydrogen and hydrogen have a +1 oxidation number. So there are 2 hydrogens. So which makes it +2. Net charge is 0. So what is the oxidation number on oxygen?
-2.
-2, and that is only one oxygen. So the oxidation number of one atom of oxygen is -2. Is this clear?
Yes, sir.
Ashal and Kubra? Okay. Now have a look at,
can you please repeat again
see, net charge was 0, right? There is no element from group 1, 2, and 3. So we comes to hydrogen, and hydrogen have usually +1 charge. So we put a +1 charge, and there are 2 hydrogen, which makes it +2. Net charge is 0. So what will be the charge on oxygen? -2.
Okay.
And as there is only one oxygen, so the -2 will be the charge of one oxygen only.
okay sir ठीक
Okay. Now have a look at this example. NaH. What will be the net charge?
0.
0. Any element from group 1, 2, and 3?
Na from group 1.
+1. So if sodium is +1 and the net charge is 0, so then what will be the charge of hydrogen?
-1.
-1. See, Kubra, that's how you can you will able to figure out when hydrogen is -1. Otherwise, hydrogen is +1. Is this clear?
yes sir okay
Okay.
सर बट हम इसमें H पहले क्यों नहीं लिखेंगे?
Sorry.
इसमें हम H पहले क्यों नहीं लिखेंगे Na से?
Recall the orders. We always write the oxidation number of group 1, 2, and 3 first. And after them, we put the oxidation number of hydrogen, right?
Okay, sir. Okay.
So if you always follow the order, you will not do the mistake. If you don't follow the order, you always do the mistake. Now, next one, PO3, that is, sorry, it's PO4 3 negative, phosphite ion. It's phosphate ion. It's a polyatomic ion. So PO4. What will be the net charge over here now?
So -3.
-3. Is there any element from group 1, 2, and 3?
No, sir.
Is there hydrogen?
No, sir.
Most electronegative one is
Oxygen.
which belongs to group 6, so its oxidation number is going to be -2. And there are 4 oxygens, which makes the net charge of oxygen is -8 and the net charge of the whole ion is -3. So what will be the charge over here that you will get -3 as a net charge?
So +5.
+5. And there is only one phosphorus, so the oxidation number of phosphorus is going to be +5 in this case. Is it clear?
Yes, sir.
Yes, Kubra and Ashal, is this clear?
जी sir.
Okay, so after this, now I am going to you a home task that you have to find the oxidation numbers of the elements in each of the given compounds, and I am writing the compounds down over here, and in the next class I will check it. It's S2O3 2 negative, Fe2O3, S4O8 2 negative, KMnO4, then ClO negative, NaClO3, NH4 positive, OH negative, NO2, N2O5, NO3 negative, CH3OH, then SO4 2 negative, CH3COOH, and H2C2O4. Always follow the order that I have told you while putting the oxidation number, so there will be no mistake and you will always get the correct answers, correct oxidation number. Take the screenshot, that is your home task, and I want this before our next class, which is going to be on Tuesday, and then I will discuss and schedule the extra classes for you guys.
So next class would be on Wednesday.
Yeah, sorry, Wednesday.
Okay.
Okay. Everybody took the screenshot?
Yes, sir.
Yes sir.
Yes. Okay, then take care, everyone. Have a good night. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.